Hi guys. We're going to first review what we did last week and then we're going to add to it just a little bit and move forward for the next section. Alright, the warm-up is just asking how you find the standard error given the mean and the standard deviation. So this is what we had to calculate last time and we just have to remember it for today as well. So standard error is the one that you actually had to calculate, and you do that, so the way it's written is baby sigma x bar. And the way you calculate baby sigma x bar is you take the population standard deviation, baby sigma, and you divide it by the square root of your sample size, and your sample size is n. So, baby sigma x bar is equal to baby sigma divided by the square root of n. What we're going to do today is we're going to put everything together that we've been doing. So we're going to find z-scores, we're going to find the standard error, we're going to find it on the chart, we're going to find the area to the right, to the left, all that stuff. I'm not going to actually calculate anything during the notes or look it up on the chart because I'm hoping you guys know how to do that by now, and my notes have been getting kind of long. And I understand that, so I'm going to try to speed it up by not actually calculating anything. I'm just going to try to quickly go through what you actually have to do. If you remember z-scores, you find z-scores by taking your x values, subtracting the mean, and dividing it by the standard deviation. Okay, and then the z-score is what you find on your chart, and then your chart gives you your area. We're going to do this today. The only difference is that the mean's not actually going to change, but it's technically going to be the population and the sample mean. And instead of using baby sigma, you have to use your standard error. So, if you think back to what we just did last time, remember when we said that the mean was equal to the mean of the x bar? That was the same thing. Mu and mu x bar are the same thing. So when you go to find your z-score, you're actually using mu x bar, technically. But it's the same thing as the mean, so you just use the mean in the same place as you did before. The different part is that instead of using baby sigma today, you're going to have to use baby sigma x bar, which is the one you had to calculate. So baby sigma, this is what we just talked about on the warm-up, is baby sigma divided by the square root of n. So you have to calculate this standard error of your mean. You have to calculate this to plug in here before you can find your z-score and then before you can find your area. So it all is just building on everything that we've been doing. This, what I just explained, is exactly what's written on this slide, okay? So to go from our x bar to our z-score, you're going to take x, which is what we have, subtract the mean, which you already know, and then you're dividing it by the square or by the standard error this time, which you find the standard error by taking baby sigma and dividing it by the square root of n. Okay, so we're just doing all of the steps. So you still have to find the mean, mu, your standard deviation, baby sigma, and your sample size, n, just like last time. Find the standard error, which is baby sigma divided by the square root of n. Plug the values in to find your z-score. So it looks complicated, but you're taking x minus your mu and dividing it by baby sigma over the square root of n, which you've already calculated up here. Okay. Once you find your z-score, then you find it on your chart, and then that'll give you the area to the left. And then if you have to do the right or in between, you have to do the same thing that we were doing before. Okay, so let's go through this. The average time adults ages 18 to 24 spend reading the paper every day is 9 minutes. Average is your mu, so 9 is mu, with a standard deviation of 1.5, so that's baby sigma. You sample 50 adults, so your sample size is n, in this age range. What is the probability that the mean time they spend reading the newspaper is between 8.7 and 9.5? So they give you two x values, so you're going to have to find two areas, and you're going to have to find two z-scores, two areas, and then subtract them from each other from your chart. Okay, so the difference is that they gave you a sample size. The fact that they give you a sample size tells you that you have to find your standard error first. So since they gave you a sample size, then we have to find the standard error. So we have to do baby sigma divided by the square root of n. So baby sigma, we already identified everything, was 1.5 divided by the square root of n, which was 50. Okay, then that'll give you baby sigma x bar, and then you can use that to find your z-scores. So that's what I said here. Mean, standard deviation, sample size, standard error is what we just calculated. So here's baby sigma x bar. So now that you have all of that, it's exactly what you just did before. So you're going to do your x minus your mu divided by baby sigma x bar, which is this 0.212. So we have to do it twice because we had two different x values. So our first x was 8.7. So you're going to do 8.7 minus 9, because that's your mu, divided by the number we just found. That's the big difference. So I have put all on here, so hopefully I'm not going too fast. So 8.7 was your x, 9 was your mu, and then this number is the baby sigma x bar we just calculated, okay? You do all that, you find your z-score. Here's our z-score of negative 1.41. That then, when you have your z-score, then you find it on your chart. So you would go to the negative side of your chart. You would find negative 1.4 along the left, you would find 1 across the top, and then it's going to spit out the area of 0.0793. That's from your chart. Okay. Okay. Sorry, this should be scooted over here. Then you had another x value, which is the only reason we're doing it again. So since we had another x value, here's your x, here's your mean, and here's your baby sigma x bar that we just calculated that you're dividing by. So 9.5 minus 9 divided by 0.212 gives you this 2.36, which is your z-score. Every time you see your z-score, you go to your chart. So you go to the positive side, you'd find 2.3 along the left, 6 across the top, and then it would give you this area of 0.9909. So this also came from your chart. Since it says between, that means you have to subtract your z-scores now, or your areas. I've seen a lot of people do this incorrectly on their homework, and I've written comments, but nobody's fixed it. Your area can never be negative, so whenever you're finding the area in between, you always have to take the biggest and subtract the smallest, every time. So our bigger one was the 0.9909, so we have to take that one first. So 0.9909, subtract the smaller one, and then the area in between, right here, is your answer. Okay? So basically there's a 91% chance that it's going to fall between 8.7 and 9.5. Okay? All right, we'll do one more. You randomly select 45 adults, ages 65 and up. Okay, you select 45 adults. That's going to be your sample size. Their mean reading time is 33 minutes. So, mean is your mu. And the standard deviation is 4. That's your baby sigma. What's the probability that they spend reading between 27 and 35? So they gave you two x values again. But again, the fact that they gave you a sample size tells you have to calculate the standard error first. Okay? So the standard error is baby sigma divided by the square root of n. So our baby sigma was 4, and you're going to divide it by the square root of your sample size, which was 45. So you would take 4 and divide it by the square root of 45. And you're going to get 0.5963 if you want to go that far. Okay? That's baby sigma x bar. That's what you're going to be dividing by each time you find your z-score. So you're going to do it twice. So you're going to take x minus mu divided by this number now to get your z-score. and then you're going to do it again. So then you'll take this x and the mean again and divide it by this number again. You're going to get 2 z-scores, so 2 areas, and then subtract them. So x minus mu divided by baby sigma x bar gives you this number from your chart. That's a giant number, and it's not even on your chart. So since it is so far negative, it's so giant and so negative, there's nothing to the left of that, so then that's going to make your area 0. Okay? If you can't find it on your chart and it's negative, the area is 0. If this were a positive 10.07 and you couldn't find it on your chart, it's because it's so big that everything is to the left of it, so then the area would have been 1. So you have to be careful. If it's really big negative, then it's 0 because nothing's to the left. But if it's really big positive, then it's 1 because everything is to the left. Okay, and then we come over here and you do this one. So here's this x, here's your mu, here's your baby sigma x bar, that hasn't changed. And then that gives you this z-score, which you can find on your chart. And when you find it on your chart, you get this number. And then the area between, technically you're subtracting them from each other, but since one of them was 0, it just is going to leave you with this 0.9996. Okay? This one, we're not going to do it really, but the mean mu, you select 9n. Okay? Probability that the mean rent is less than, so that's your x value with a standard deviation of 150. Less than means left, so that's what your chart gives you. So all you have to do is calculate it with this single x value, find what the chart gives you, and then that's it. This one says the average price, so average, average is mean, mu. You randomly select 16 houses, so that's your n. That is more than this value, and the standard deviation is 26,000. Now, more than means right. Remember that your chart doesn't give you the area to the right once you do all the work, so you have to first find baby sigma divided by the square root of n would be your first step. So you would take 26,000 divided by the square root of 16. That gives you baby sigma x bar. Once you find that, then you're going to use your x value, your mean, and whatever you get from this to calculate your z-score. Once you have your z-score, you find it on your chart. So again, this was so big negative that the area was 0, but we didn't want the area to the left, we needed the area to the right. So because it was more than, so you take 1 and subtract 0 and you get 1 as your answer. So just still pay attention to the wording. More than's to the right, between you have to find 2, less than's to the left, which is what your chart gives you. Okay? Alright, hopefully that makes sense. I didn't go too fast, but I'm trying to make it a little bit quicker for you guys. 15 through 18 all on 5-4B. We only have a couple sections of notes left at all for the whole year. So we're getting close to the end, and then I'm hoping we're going to have a little bit of time to do something a little bit more fun before you guys are done. So, all right, that's it. Hope you guys are all doing well. Miss you all. Bye, guys.